For an enzyme and a substrate to react, the surfaces have to be complementary to each other. We refer to this as enzyme specificity, which is the ability of an enzyme to bind to only one or maybe very few substrates. As an example, take a look at urease. Now, urease is a very specific enzyme. Another way of putting this is to say it has a high degree of specificity. So those mean the same thing. If urea is treated with urease, you end up with the products of carbon dioxide and ammonia. Whereas if I take methylurea, which is very similar in structure to urea, and treat it with the same enzyme, urease, I get no reaction. Thus, even though methylurea is very close in structure to urea, urease is so specific it can recognize urea as the only enzyme that has the ability to bind. Not all enzymes exhibit the same degree of specificity. 4 classes of enzyme specificity have been observed. Absolute specificity. An enzyme that catalyzes the reaction of only one substrate has absolute specificity. Group specificity. An enzyme that catalyzes reactions involving similar molecules containing the same functional group has group specificity. Linkage specificity. An enzyme that catalyzes the formation or breakage of only certain bonds in a molecule has linkage specificity. Proteases like trypsin, chymotrypsin, and elastase are enzymes that selectively hydrolyze peptide bonds. Thus, these enzymes are linkage specific. Stereochemical specificity. An enzyme that can distinguish one enantiomer from another has stereochemical specificity. Most of the enzymes in the human body show stereochemical specificity. Because we use only D sugars and L amino acids, the enzymes involved in digestion and metabolism recognize only those particular stereoisomers.